important topic we are taking, that is temperature dependence of resistivity. Temperature dependence of resistivity. Temperature dependence of, or we can say that, resistivity and temperature. Resistivity and temperature, or temperature dependence of resistivity. We know that resistivity, that is R, is equal to rho L by A. Also, rho is equal to R A by L. Resistivity is also, that is very simple, M upon N E square tau. Now let's explain the temperature dependence of resistivity. For already we have discussed that resistivity does not depend on the dimension of the material, but only depends on nature of the material as well as temperature of the material. Now, it has been observed that over a limited range of temperature, the variation of resistivity with temperature is expressed by a relation given in NCERT, that is rho T is equal to rho naught 1 plus alpha T minus T naught. T minus T naught. Where what is this and what is this and what this term? This is nothing but this is, that is, value of resistivity at temperature T is equal to 0 degree Celsius or 273 Kelvin. What is this? This is the value of resistivity at any temperature T. This term is very important. This term, that is alpha. Alpha is nothing but it is known as temperature coefficient of resistivity. This is called temperature coefficient of resistivity. This is nothing but it is temperature coefficient of resistivity. This is alpha. Alpha is nothing but it is temperature coefficient of resistivity. Very important term. So this is rho T is equal to this one. Now this is clear now. Again I am writing this, that is rho T is equal to rho naught 1 plus alpha T minus T naught. Now let's take a little bit explanation of alpha, what this alpha and what it tells about. From this relationship we can find out alpha is equal to rho T minus rho naught divided by rho naught T minus T naught. Now this is nothing but this is change in resistivity, that is the difference between resistivity at temperature T and resistivity at temperature, that is 0 degree Celsius. This can be written as delta rho upon rho naught, and this is T minus, that is delta T. We can define it as, now what is alpha now? Alpha is defined as the change in resistivity per unit original resistivity per unit change in temperature. What this what is the meaning of this statement? This is nothing but how much deviation will be in the value of resistivity from its original value of resistivity at standard temperature when there is a unit change in temperature. So we can say that temperature coefficient of resistivity is defined as change in resistivity per unit original resistivity per unit change in temperature. This is a very important term to understand the variation of resistivity with rise in temperature. Now if we take, now we have especially two types of material. First is conductor like metals, then we have semiconductor, then we have alloys. Now question can be asked, what will be the value of alpha for metals? For metal, alpha is always positive. What is the explanation? Means when the temperature of a metal is increased, with increase in temperature there is increase in the value of resistivity. That is, if T rises, the resistivity also rises. Means with rise in temperature the resistivity also increasing. It's a very important point. For metal we can say that if alpha, that is positive, means if temperature is increasing, with rise in temperature there is rise in the value of that is resistivity. Now let's take the relationship between change in temperature and resistivity for three types of material. First we are taking for metals, what will be the pattern of variation. First we are taking metal. Metal resistivity versus temperature. Now alpha is positive. Alpha is positive means temperature is increasing, there is increase in the value of resistivity. Very simple. Now it has been observed that at low temperature, very important point, at low temperature what happens to the conductor? Conductor like aluminium and copper have non-linear dependence. Non-linear dependence, a very minute observation, that is for it is resistivity and this is temperature. For low value of temperature, like if we take this is 50 Kelvin, this is 100 Kelvin and this is 150 Kelvin. For copper, aluminium, the pattern of graph is like this way. The pattern of graph is like this way. This way. These are the experimental observation already given in NCERT. That is, the resistivity increase linearly with increase in temperature from room temperature to higher temperature. Up to lower temperature, you can see that the graph is not linear, but it is non-linear. But when we rise the temperature from room temperature to higher temperature, there will be the linear relationship. Very important point. Sometime in board examination, question is asked. That is, draw resistivity versus temperature graph for metals like copper and aluminium and other material. Second, let's take second is Ly. Second material, we are taking only those material which are given in NCERT. For material Ly, ALLOY. Now what happens in Ly? Ly is nothing but is the combination of more than one or more than one metals. Now what happens in Ly? That is also experimental observation. If we are taking the graph for Ly, this is resistivity versus temperature graph for Ly. What happens? With rise in temperature, how the resistivity of Ly material changes. It has been observed that for alloys like nichrome, constantan, the dependence, the variation of resistivity with temperature is very less. We can see here there is a little variation even at higher temperature. This variation is very small. It is up to large range of temperature, the value of resistivity changes minutely. Now we can say that the resistivity in case of Ly is somehow independent from temperature. That is, resistivity up to certain range of temperature, that is certain value of temperature up to higher value, means if we are increasing value of temperature up to higher value 500 Kelvin, 700 Kelvin, we find that the value of resistivity changes very minutely. So that is why question sometimes can be asked why we prefer alloys or alloy material for making standard resistor. Reason is very simple. Standard resistor means the value of R will not vary with rising temperature. Now what happens? Suppose if we are taking this wire is of Ly. If we are taking any wire which is made of Ly and we are giving a current I, if time duration is increasing, what happens? After some time the wire will start heating. Now if heating of wire is increasing, what happens? The resistance is also starts increasing. If this is a conductor, the resistance increasing up to maximum extent. If initial resistance is I, suppose this is initial resistance Ri, after some time if the whole material get heated up, it will increase up to large extent in case of conductor. But if we are taking Ly material, no matter for how much duration current I is flowing, even the value of Ri remains approximately equal to Ri even after a longer time. It means that there is a very small change in the value of resistance, or we can say that resistivity. So that's why we prefer Ly material for making standard resistor. So you can see here how the value of resistivity changes with the rising temperature in case of alloys. Alloys are nichrome, constantan and manganese. For all types of alloy, this behavior is there. What is the final conclusion? That there is a minute change in the value of resistivity of alloy with rise in temperature, up to maximum value of temperature. Or we can say that the resistivity of Ly is totally independent from the rise in temperature. Now last one. Last one is nothing but semiconducting material. Very important, that is semiconductor. The behavior of semiconductor, it is totally different. Now let's take, according to NCRT, this is resistivity and this is temperature curve. The value, the behavior of Ly is like this way. What this tells? It tells it that with rise in temperature, the resistivity of semiconductor material like silicon, germanium starts decreasing. Means if resistivity starts decreasing, means whenever temperature is going up to higher and higher value, the value of conductivity starts rising. So this is a very different behavior, that with rise in temperature, the value of resistivity of semiconductor material starts decreasing. In all examination, last 3 or 4 examination, the question has been asked many times. Sometime 2 marks, sometime 3 marks. Very simple question, that is, show the graph between resistivity and temperature for copper, for silicon, and for it is other material like alloys, copper, germanium, and silicon. So this is the behavior. Now, in other way, we can also explain this behavior of all these three. We know that resistivity is equal to m upon Ne square tau. Ne square tau. In case of metal, if T increasing, now what happens? Now see here. In case of metals, number density always remain constant. If this is a metallic wire, the number density, number of charge carrier per unit volume always remain constant. There is no change in rise in temperature. But what happens? There is a change in this tau, relaxation time. That is the time between two successive collisions. If temperature is higher, what happens to this? It will decrease. Yes, it will decrease. If this tau is decreasing, what happens to the resistivity of the metal? Very simple. The resistivity of the metal क्या हो जाएगा? बढ़ जाएगा. It will increase. This is the first explanation. Is it clear? Second, what about in case of semiconducting material? Semiconducting material. Now what happens in semiconducting material? In semiconductor, what happens? With rise in temperature, that is with rise in temperature, two things are going to change. Number one is N, number two is tau. Now what happens? Because whenever temperature start increasing, number of covalent bond breaks in case of semiconductor, and due to breakage of covalent bond, the charge carrier starts increasing, means N starts increasing many times. Similarly, temperature increasing and number increasing, what happens to tau? Tau starts decreasing because temperature goes increasing. Then the relaxation time, that is the collision become very fast.